better. All right, so today we're going to learn about oblique triangles. And an oblique triangle is a non-right triangle. So when we refer to an oblique triangle, that just basically means the triangle is not right. And so we've got two ways in which we can solve oblique triangles. The first way is known as the law of sines. The second way is known as the law of cosines. Now, we did briefly cover these in geometry towards the end of the year.
Yes.
So this should be somewhat of a little bit review. It might be some new stuff too, but a little bit about the law of sines. If you remember, what this AAS means is that AAS means angle, angle, side. So when you know an angle, angle, side in a triangle, you can use the law of sines. ASA, remember, meant angle, side, angle. So if you know the angle, the next side, and then the next angle in a triangle, you can use the law of sines. And last but not least, the side-side angle. This is side-side angle. It's what we call the ambiguous case. And remember, with the law of sines, we had a special thing we needed to do when we had the ambiguous case, and we'll cover that. And then we'll get to the law of cosines, which deals with side, 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 and side, angle, side. So today, this is what we're focusing on. We are focusing on the angle, angle, side case and the angle, side, angle case. Tomorrow, we're going to learn about the ambiguous case with the law of sines. And then, Wednesday, we're going to learn about the law of cosines. Okay, so first of all, today's lesson should be fairly easy. Remember that the law of sines is defined as being the sine of angle A over side A equals the sine of angle B over side B. Now notice, I have repeated again that we use law of sines for angle, angle, side, angle, and the side, side, angle ambiguous case. I must think it's pretty important if I put it on two slides. Okay? You need to remember, law of sines, you use angle, angle, side, angle, or the side, side, angle. And no, I don't want you writing that the other way. We write that as side, side, angle, if you haven't figured that out.
What's ambiguous?
Okay, ambiguous means you don't know if you're going to have one solution or two solutions, and we'll talk about that tomorrow. So now, oops, skipped that one. It says to solve triangle ABC. So whenever we say to solve a triangle, remember this is from your test, solving the triangle meant find all missing sides and angles. So in here, notice you're given 3 parts of the triangle. That means you need to find the other 3 parts. And so what I suggest you do is you make like a little answer key. And notice I have this answer key written at the bottom right of this slide. And I need to find angle A, I need to find side A, and I need to find side C. And so in this triangle I'm given, C is 102.3, B is 28.7, and side B is 27.4. Now you may need to draw a triangle, and if you want to, that's fine. You don't have to though, but it might help to visualize things. Here is angle C. Let's just say that this is angle B up here, 28.7, and then side B is 27.4. And so what I need to do is I need to find angle A, side A, and side C. So in order to solve law of sines, you're looking for an angle-side combination. When I say an angle-side combination, in this case that means 28.7 and 27.4. They are an angle-side combination. And so I'm going to use that in my law of sines. I've got the sine of 28.7 divided by this 27.4. That's going to equal. Now in this case, I need to go ahead and use the 102.3. So I'm going to take the sine of 102.3, and that will be over side C. So this is a basic proportion. Okay, not too bad. All you need to do to solve that, this is the easy way if you want to do it all in one step. Multiply these two, and then divide by sine of 28.7. Now if you do that all in one, I'm going to give you a hint. 27.4 times sine of 102.3 divided by Okay, I would put a separate set of parentheses around that. And so what does C come out to be? And we usually round to 100. 55.75. Did somebody else get that? Mm-hmm. So I've got a second and a third. So that means side C here is 55.75. Now I need to find the remaining two things. And so one of those is going to be fairly easy to find. And what one is that? Angle A. Yep. So angle A I can find by taking 180 minus 102.3 minus 28.7, and it comes out to be 49 degrees even. Okay, so there's your 49 degrees. So now what I need to do lastly is find side A. Now if I were you, I would stick with what you were given in the problem. And I would use this right here. Okay? It is a non-right triangle, so you cannot use a squared plus b squared over c squared. So here you are again. Now, oops, sorry, this is a little hint. If you notice, if you compare what I have written in the orange here, right here, to what I have written in the green, what's the difference? What's the only difference? The sign of 102.3. And so really what you could do on your calculator if you wanted to, hit the second and the enter button and you can recall that previous statement in green, and then all you need to do is change that in green to orange if you want. Otherwise you could just type it all in again. And when you type that all in again, what do you get? What do you get for A? Somebody else get 43.06? Now real quick, we need to check. Largest angle needs to be opposite the largest side. Okay? Smallest angle needs to be opposite the smallest side. Is that true? So then we're done with the problem and we're good to go. Okay. So that's one type of problem you're going to have. This is going to be the second type of problem. So instead of using it just in symbols, you've now got a picture. So this is actually a little bit easier because we don't have to draw the pictures we did in the problem before. Once again, we're finding angle T, our side S and side T. So what do you want to do first?
63 over 13, or sine 63 over 13
okay.
equals sine 51 over S.
Okay. Good. So remember, this is side S here. This is side T. So on your calculator, what you need to do, 13 sine of 51 divided by sine of 63. So 13 times the sine of 51 divided by the sine of 63. 11.34. Did somebody else get that? Second, third? Now what do we know?
Sine S.
Okay, we know what side S is. What else?
We can also find side T. Pythagorean theorem.
Can't use a Pythagorean theorem.
Well, we can take 180.
Yep, take 180 minus 63 minus 51. So 180 minus 63 minus 51.
So what do you get?
76 degrees?
66.
66 degrees. Oops, I missed that 51. So 66 degrees right here. And so we're going to go ahead and use our law of sines. So the only thing that I'm going to change here, instead of it being 51, I'm now going to change this to 66. And so when I do that, I should have 13 times sine of 66 divided by sine of 63. And what do you get?
13.33.
Somebody else get that?
Yes.
Final check. Largest angle needs to be opposite the largest side. So what's the largest angle? 66, it needs to be opposite the 13.33, which it is. Smallest angle needs to be opposite smallest side. 51 degrees is opposite 11.33. What do you think?
For that, do you put 13.3 repeating, or do you have to do 13.33?
I would prefer you do the 13.33.
It's not repeating.
It's not repeating.
Okay. Reason being, I want you to know that you've rounded to 2 decimal places though. Okay, very last problem we're going to look at today. A satellite is passing between the Oak Ridge Lab and the Langley Research Center, which are 446 miles apart. If the angles of elevation to the satellite from Oak Ridge Lab and Langley facilities are 58 degrees and 72 degrees, how far is the satellite from each station? So what I'm trying to find are what are A and B in the diagram. But in order to even find A or B, what do you need to do first? Find angle C. Yep. So what is angle C going to be?
180 minus 58 minus 72.
Yep, which is?
43.
Which is what?
43.
Or I put 79. It's 50.
I think it should be 50.
It is 50.
Because 72 and 58 are 130. So subtract from 180, you get 50. So first thing, let's find how far it is from Oak Ridge. So to find how far it is from Oak Ridge, I'm going to go sine of 50 divided by 446 equals sine of what if I want to find how far it is from Oak Ridge? Sine of what? 72, good, over B. So go ahead and use your proportions, 446 times sine of 72 divided by sine of 50. And so from Oak Ridge, .72, label will be miles. Okay. Now what we need to do is find the exact same thing from Langley. So what's going to change in my problem? Sine of 72 will now be sine of what?
Sine of 58.
58. So go ahead and do that. So from Langley, how far is?
493.74.
493. Do I have a second? Do I have a s- you got what? What else do we have? We evidently have a discrepancy. What is the answer going to be? What? 493.74? Okay, there you go. So questions on law of science today? Think you can handle that? Here's your assignment, 1 through 9 on page 298. Tomorrow, all we're going to do is look at strictly the ambiguous case. And then the next day, the law of cosine.
Kaylee looks over.